Okay, quick video here looking at the 2021 QCAA external exam multiple choice questions from paper 1. Here we go. First question, we have the simple log question. So we're going to use our log laws in this question here. So we're going to start off with looking at, well, this is log base 10. So I'm going to just write down here log, and I use my log law to bring the 2 up here. And then minus the log, again log base 10, I don't need to write the 10, the 3x equals log of x squared over 3x, and we can simplify that. That gives us log of x over 3, which is answer A. Okay, the second question we are going to look at here is going to be the table shows the time a technician has spent servicing photocopiers. So they give you the information there. They want to know the probability that a given service required at least 10 minutes but less than 20 minutes. So in that particular question there, we're going to look at our table and get our information from there. So we look at the frequency. Well, the total of the frequency, if you add all those up, 10 plus 20 plus 30 plus 40 plus 100 should give you 200. We're interested in between 10 and 15 and 15 and 20. So we're interested in 30 plus 40 out of a total of 200, which gives us 70 out of 200, or simplified 35 out of 100, or as a decimal 0.35, which is answer B. And moving on now to question number 3, where we have a bit of an integral question here. So we've got the integral of 10 e to the 4x dx, and you could write that as 10, the integral of e to the 4x if you like. I tend to like doing that, bringing that 10 out the front, and that of course is going to be 10 multiplied by e to the 4x, integral of e to the 4x is just e to the 4x, over the derivative of that 4x, which is just over 4. We of course can simplify that to 5 over 2, so we get 5 over 2 e to the 4x, which is answer C. On now to question number 3, and question number 3 asks us to look at, question number 4, consider the second derivative of the function. They give you that, so the second derivative is, in fact, I'll write this one out, 2x over 1 plus x squared, and we're asked to find the interval over which the graph of the original function, f of x, is concave up. If we look at where the point of inflection occurs, if you just look at the answers A, B, C, D, you should be able to see that the point of inflection is at 0, because you've got A less than 0, for less than or equal to 0 for B, C, x greater than 0, and so on and so forth. But if you wanted to work that out, you could set that equal to 0, of course, and you would have 2x over x plus, 2x over x, or 1 rather, plus x squared, and of course you get x equals 0, so that's your point of inflection. Of course, that's the point where the graph changes from concave up to concave down. We just simply want to know, well, what is the, at the point 1, what is the nature of this? Is it positive or is it negative? So if I substitute 1 into here, 2 times 1, 2 divided by 1 plus 1, that's going to give me 1, and of course that is greater than 0, therefore that is concave up. So our answer we're looking at is for values of x greater than 0, which is concave up, which is C, answer C. For question 5, we're going to be looking at another derivative type question where they're asking us to consider a function that they give us here. So they give us a function looks something like this, and they want to know, well, that's the second derivative. They want to know a possible solution of the first derivative. So if you consider this in terms of gradients, you're going to have on this graph, original graph here, this is positive. Anything above the x-axis is going to represent positive gradients. Anything below that x-axis is going to represent negative gradients. So if you think about in terms of your answers A, B, C, and D, part A starts off with a positive gradient up until the point 1. Up to the point -1 and then continues on positive. No, our graph goes negative after that point, so it's not A. B, if you look at their answer for B, it's a negative gradient, so no, it's not going to be B because it starts off with positive. C starts off with a negative gradient as well, the graph's going down, so that's not going to be the answer. D is a positive gradient to begin with. At 1, it's a turning point, and then it changes to a negative gradient. So that's this part here of our second derivative. And then at positive 1, it turns and goes up again, which is a positive gradient. So our answer is D for question number 5. Okay, question number 6 on our multiple choice. We have got a random variable x is the number of successes in the Bernoulli experiment with n trials, each with a probability success of p and a probability failure q. The probability distribution table is shown and they give you that there. The easiest way to probably think about this is to think about your binomial formula. They're asking in particular which values of n, p and q will generate that distribution. An easy way to look at this is to consider the probability of x is equal to 0, because that's either going to be failure, which is q to the power of 4, or q to the power of 5. Now, why am I choosing 4 and why am I choosing 5? Because if you look at their answers, A, B, C, and D, you've got n equals 4 or n equals 5. So they're your two choices. So if we look at the values we're given, we could just try some of those values out. So they, for instance, have Q as being, for part A, as being 1/3. So if I did Q to the power of 4, 1 over 3 to the power of 4, that of course is 1 over 81. So 1 over 81 should represent our probability of x equals 0. And if you look at the table, the first value there, they've got k is equal to 0, probability of x is equal to 0 has been 1 over 81. You don't really need to test anymore. I could have done the same thing with p of x equals 4, and then I'll be looking for an answer that would give me 16 over 81, and I would have used the p-value of p-value, which they give you of 2/3, so I would have done 2/3 to the power of 4, which would have given me 16 over 81. So either way, but that's probably the easiest way, just choose one of those. We don't need to go through and test the rest because we've already got our answer. Alrighty, now question number 7. We have got a question where we're looking at the integral, a definite integral between 1 and 3 of 2x plus 3. Now that's equal to x squared plus 3x. If I integrate that one correctly between 1 and 3, I'm then going to do my substitution, making sure that I know that 3 squared is equal to 9 plus 3 times 3, which is 9. Subtract 1 plus 3 times 1 is 3. That is going to give me 18 minus 4. 18 minus 4 is 14. Your answer is C. So easy one there. All right, second and last question. Moving on to question 8. We have got the continuous random variable x has a probability density function given there. The mean of x. So calculate the mean of x. You can use your formula sheet for this one. You're going to have the integral between the lower bound 1 and upper bound 3 over 2 of the function, which is, of x times the function, which is 3 over x squared dx. So that's straight from the formula sheet. Using that formula, before we integrate, we can simplify this a little bit. So we get 3 ln x between 1 and 3 over 2. And if we simplify that a little bit further, we could say that's the same as ln x. Bring the 3 up here, so it gives us cube between 1 and 3 over 2. Now if I do my substitution, I will get ln of 3 over 2 cubed minus ln of 1. Now ln of 1, hopefully you know that that's 0. So our answer for this one is simply going to be ln, and it's b, 27 over 8. Answer B for question 8. All right, on to question 9 now, and question 9 is asking us to look at a basket that contains 10 green apples, 30 red apples, 3 apples are drawn at random from the basket. So we've got 40 altogether in the basket. We're drawing 3 at random with replacement. So they're independent events. Determine the probability that exactly 2 of the 3 apples are green. Exactly 2 apples, we're dealing with binomial, so we're looking at the probability that x is equal to a particular value. In this case, it's 2. So we're looking at choosing 3. Sorry, we're looking at the probability of exactly 2 from 3 that are going to be green. So the probability of success for green is going to be 10 out of the 40, or 1 over 4. Using our binomial formula, that's 1 over 4 squared. And then the probability of failure, 3 over 4. It's a power of 2, 3 minus 2, which is 1. So simplifying that now, some people might look at the 3C2 here and think, oh, I'm not sure how do I go about solving that? What do I do? If you're really stuck, you can actually use set up a little Pascal's triangle and write this out as sort of 1, 1, 1, 2, 1, 3, 3, 1. That's as far as I need to go, because we're looking at 3, choose 2. So we're looking at the third row. So this is row 0, row 1, row 2, row 3, and then we're looking at the 0, first, second element. So our second element is here, is this one here. This is what we're looking for. So our 3C2 is going to be 3. Some of you already know that, so you won't need to do that little Pascal's triangle, but that's what you can do in the exam. That's perfectly acceptable. Now 1 over 4 squared gives me 1 over 16 multiplied by 3 over 4, and we can simplify that to 64. 3 3s are 9 out of 64, which is answer B for question. Okay, question 10, the last one in the multiple choice section. Question 10, we've got the hand spans of teenage approximately normally distributed with a mean of 15, standard deviation of 2. Which of the following groups is expected to be the largest? So if we look at the answers there, A is between 7 and 11. So if I was to draw a little binomial distribution here and write in our mean is going to be 15, where is 11? Well, that's going to be right down here. Or maybe, sorry, 11, the standard deviation is 2. So 15, 13, 11, it's going to be 2 standard deviations away. But 7 is going to be right down here somewhere. So it's really this area here, very small area there. So that's for A. For B, you're looking at the area between 11 and 15. So 11 and 15, 2 standard deviations away. So it's that area there. For C, you're looking at, I should write those in there, 11 and 15. For C, you're looking at an area here that is between 13 and 17. 1 standard deviation on each side. Now you should know that 1 standard deviation each side is about 68% of the data. Now if we look back here, if you go 2 standard deviations to the left here, that represents a little bit less than 50%. So Of course, 50% is all of this. So far, this is about 47.5%, I think. So far, C is the largest. D, they want to know what the area is between 17 and 21. 21's right out here, so it's going to be a small area. So we're looking at answer C for question 10.